Hello again, Year 8, and welcome to Lesson 3 of Acids and Alkalis. So, what do you need today? As well as your booklet, you need a pen, ideally blue or black. You need a pen in a different colour, so that you can show where you've made corrections or marked work. You need some colouring pencils, felt tip pens or wax crayons. And you may also need some extra paper as we go through. You also will need your spider diagram from the last lesson. So, our lesson objectives for today. You're going to be able to describe what litmus is. Hint there on the left with the picture on the left. You're going to design an experiment for testing litmus as an indicator. And you're going to conclude how litmus can be used to identify acids and alkalis. So, as I mentioned in the previous lesson, I want you to get your spider diagrams out. Add a new branch for lesson 2 with a circle or square around it to show it's a heading, and add at least 3 things that you remember from last lesson as a form of retrieval practice. Remember, if you do need to go back and look in your booklet, anything you add that you've taken directly from your booklet and not from memory, you add in a different coloured pen. So pause the video now while you do this. Okay, hopefully you've now finished your spider diagram for today on lesson 2. So we're going to learn about litmus. Litmus is a common indicator for acids and alkalis. It is made up from a species of a lichen. And this is how you spell lichen here. It's a bit of a weird one. You pronounce it a bit different to how you would spell it. Now, lichens are plants which live on the bark of trees or on concrete or stone. And you can see one here. You can see them anytime you go out and look at trees and stone, as long as you're in an area of good air quality. If you went down Port Talbot, where the steelworks are, you wouldn't see much lichen because of the contamination in the air from the steelworks. So litmus is often used in the form of paper strips called litmus paper. And you can see here an example of 2 litmus papers. Now, there's a note of warning when we're talking about litmus paper. It should mean strips of paper that have the litmus indicator in them. There are 2 types. Red litmus paper for testing alkalis, which would turn blue in an alkali, and blue litmus paper for testing acids, which turns red in an acid. So here's your blue litmus paper turning red in an acid, your red litmus paper turning blue in alkali. However, the name litmus paper is often used for paper strips of other indicators, which use different colours. So if you look things up online, you need to be careful. For example, I went on Google Images and typed in litmus paper, and this is what I got. So you can see here lots of strips of paper with lots of different colours. Now, all of these are not true litmus paper. They are paper for testing acids and alkali, but it is not litmus they are using. Only these 2 are litmus paper, and I know this because I know litmus paper is either blue or red. So just remember this if you do look anything up online to do with litmus paper. So today's fun fact zone is that the use of litmus to test for acids and alkalis can be dated back to around 1300. That is a very long time ago. A Spanish alchemist called Arnaldus de Villanova is credited with its discovery. Now you'll notice that I've put alchemist here, not chemist. This was a change in name. So back in the day, scientists were often called alchemists. And they were very interested in how to turn substances into gold. Now, around the 17th century, late 16th century, we had the Renaissance in Europe, and people moved to having more scientific method, and we started calling them chemists. Now, not many people knew of the work of Arnaldus, and Robert Boyle, who you'll hopefully remember from last lesson, discovered the litmus again in the 1660s. I remember this is a time long before internet or phones, so it wasn't easy for information to travel. Now, Arnaldus wrote notes, but he didn't necessarily share those notes. So Robert Boyle rediscovered it in the 1660s without knowing about Arnaldus's work. So despite being discovered twice, litmus paper was not created until the early 1800s, although we do not know for certain who created it. We haven't found specific notes about who made it or exactly when. This is why it's really important to record your results and keep everything neat and tidy. So, your first main task for today is you're going to plan an investigation to find out how litmus works as an indicator for acids and alkalis. So I want you to write a step-by-step instruction text. So to write your own method. So pause the video and have a go at doing this now, and then I will show you what I came up with. Okay, hopefully you've had a go at this. If you are going to make any corrections, remember we do that in a different coloured pen. Now, as I go through this, it is important to remember that you don't need to match mine exactly. You just need to have the same general idea. So I put 1, take a test tube and add 1 centimetre cubed hydrochloric acid. 2, add a few drops of litmus indicator and record the colour change. 3, take a new test tube and add 1 centimetre cubed of sodium hydroxide. 4, add a few drops of litmus indicator and record the colour change. 5, take a third test tube and add 1 centimetre cubed distilled water. And 6, add a few drops of litmus indicator and record the colour change. Now, hopefully you've done an even better job than me and used time connectives in your plan. That would be brilliant. If you've done it as a paragraph, that is okay, as long as it is clear. Normally we would say for method should be in bullet points or numbered steps. So as long as you've got some key steps, or you said that use a known acid or a known alkali, if you couldn't remember the name of one, that is also okay. So you have this table in your booklet. The left column, you're going to write in chemicals which turn litmus red. This is going to be a mix of laboratory chemicals and household substances. The middle, you'll put in chemicals which do not change the colour of litmus. On the right column, you'll put in chemicals which turn the litmus blue. So I'm going to show you the video now of the experiment, and you need to fill this in as we go. Okay, so here you can see our litmus indicator, and we're going to go through testing the different things. So our first is we're going to test hydrochloric acid by adding a few drops of litmus indicator. Tankoff there's adding quite a lot, so you can get some nice strong colour for the video. So, turned red, so you would add hydrochloric acid in the column of your table that asked for things that turned red. Next up, ethanoic acid. So I'm going to add this to the right column in your table, the correct column in your table, sorry, not the right hand side one. Sodium hydroxide. Then got sodium carbonate. Got distilled water. It's gone a sort of dirty purple, I would call that, which is what happens to the litmus when it's diluted. So that means it's not changed colour. Same for sodium chloride. Got our SIF surface cleaner. Our orange juice. our shampoo, our soap, our ketchup, and toothpaste. Okay, so hopefully you filled this in. So we're going to check it. Now if you need to, you can go rewind the video and watch it again. So before we go through the table, at the top of it you've got these two flasks. I want you to label one as an acid and one as an alkali and colour them in the colour the litmus goes. So pause the video quickly while you do this. Now, hopefully you coloured one in blue and label that alkali. Doesn't matter which way round you label them. And you've coloured one in red and that's your acid. So it doesn't matter which way round as long as you've got both. So here is our table of results. So if you do need to make any changes, remember you use your different coloured pen. So chemicals which turn the litmus red should have had hydrochloric acid, ethanoic acid, orange juice and ketchup. Chemicals which do not change the colour of litmus, distilled water, sodium chloride, shampoo and toothpaste. And chemicals which turn the litmus blue, got sodium hydroxide, sodium carbonate, SIF and soap. Now, from our previous lesson, when we used the red cabbage indicator, we should know whether or not these are an alkali, an acid, or neutral. So using that knowledge and the colour it says in our table it's turned, I want you to fill in the conclusion. So you'd say it goes in one colour for an acid, red in acids. So pause the video while you do the rest. Okay, so the rest you saw, it turns blue in alkalis, and in certain solutions litmus does not change colour, and these solutions are said to be neutral. If you did need to make any corrections, remember you do it in your different colour pen. Okay, so we're going to learn a bit more about litmus paper now. So as I said before, there's two types of litmus paper. Now, red litmus paper is used for testing alkalis. So what that means is, if you dip red litmus paper in an acidic solution, in an acid, it will stay red, nothing will happen. If you dip it in a neutral solution, so for example water, it will also stay red, nothing will happen. But if you dip it in an alkali solution, such as sodium hydroxide, it will turn blue. Now, blue litmus is the opposite. If it's added to an acid solution, say hydrochloric acid or orange juice, it'll turn red. In a neutral solution, like water, it'll stay blue. And in an alkali solution, it will also stay blue. So it's a bit limited, but you can see how it could be used. Now, based on that information, I have a problem for you. I've called it the Robert Boyle problem. Now, Robert Boyle's assistant forgot to label this conical flask here, and he has forgotten what he placed in it. Now, he knows Robert Boyle will get angry if he can't identify what is in the flask. You should remember that from last lesson, that is, his anger about these things is what caused him to discover his red cabbage indicator. Now, the assistant thinks it is water, but can't remember. He has two books of litmus paper, one red and one blue. So how could he use this to find out if it is water in the flask and not an acid or alkali? Now, I want you to write this down either at the back of your booklet, or if you've got some space, on a different bit of paper. Now, you may want to take the video back to look at that table again to help you with this. So pause the video while you have a go at this. Okay, hopefully you've now come up with a solution for Robert Boyle's assistant. So we'll go through my solution and see if it matches. So, the assistant could use the litmus paper to find out if it is water in the flask. First, he could dip the red litmus paper in the liquid. If it stays red, then it must be either an acid or neutral, so water. He could then dip blue litmus paper in the liquid, and if it stays blue, then it must be neutral, water. If either changes colour, then it can't possibly be water. It would have to be an acid or an alkali. Now, hopefully you got something along these lines. Again, it doesn't have to match what I've written here, but you got the idea that he would need both types of litmus paper to not change colour for it to be water. Okay, now before you finish the lesson, you need to do your self-marking quiz labelled Lesson 3 to make sure that you check your understanding and your teacher can see how you're progressing. And you also need to remember to add any new words to the table at the front of your booklet. So there's quite a few new words here that might be important to put there. So thank you, Year 8, and I will see you again for Lesson 4.